right, section 3.4, proofs with perpendicular lines. Okay, if you don't remember perpendicular from, I don't know, a chapter ago, perpendicular lines are two lines that intersect to form a 90-degree angle or form a right angle. So before we discuss perpendicular lines, we first need to discuss this idea about a distance from a point to a line. If I'm looking at this line M and this point A, and I want to know the distance from point A to line M, okay? So I could measure it. How far away are they? But if I measure, let's use metric. If I measure here, from here to here, here's from point A to the line, I can get 3 centimeters. I can also get 2 centimeters, okay, if I go there, so forth and so on. So when we're talking about the distance from a point to a line, it needs to be that perpendicular distance. Okay, so when I'm talking about that distance from a point to a line, I'm talking about this perpendicular distance. So I'm talking about this distance right here, meaning it makes a 90-degree angle. I'm looking at that distance because that will be the shortest distance. So we need to make sure we're perpendicular. So if I'm looking for, find the distance from point A to line BD. Here's point A, here's line BD right here. So I'm going from this point. Let's get some highlighters. If you don't have highlighters, go get them. You'll need highlighters. You'll also need a compass and a straight edge. We have some constructions today. So make sure you have a compass and a straight edge. So I'm looking for the distance from that point to that line. Okay. And they give us a few different points. They give me B, they give me C, they give me D. Well, if I'm looking for the distance here, good chance I'll probably be using the distance formula. If you don't remember that, go back and reference your notes. Or it is on the wall in the math room. X2 minus x1 squared, subtract the x and square it. Add that to subtracting the y's and square it. Okay. But which points do I use? I know I'm going to use this point, this one right here. But do I use B, C, or D? Well, I need to have that perpendicular distance. And so if you notice here, they give me that little red right angle there. If I didn't know that, I wouldn't know which point to use. Okay, so that tells me I need to use point then C for my other point. So then I'm going to go ahead and plug that into that distance formula. Distance formula equals the square root of. So now I have negative 3 minus the 1 squared. I took the x's, negative 3 minus the 1 squared, plus, and then 3 minus the negative 1 squared. So negative 3 minus 1 is negative 4. Need to square that. 3 minus a negative 1 is 4. Need to square that. So then I end up with the square root of 16 plus 16, which ends up being the square root of 32. Right now, approximately's are okay, which is approximately, we type that in our calculator, 5.7. And that's distance, so it would be units. Approximately, there's the exact. There's the approximately. We'll get to a point where we won't want approximately's and we'll want to do something with that square root of 32, but we're not there yet. It's coming. Okay. All right, so then now, if we remember what a perpendicular line was, now we are going to construct one. I'm going to construct a line perpendicular to M that goes through P. Okay. So to do that, again, I'll need a compass, and a straight edge. Okay. So to do that, I start by drawing an arc with the center of P. So I put my point at P, and now I'm going to draw an arc. And I want this arc to cross my line in 2 spots. So just stretch out farther than your line. Really doesn't matter how far you stretch out. You just want to make sure that it'll cross your line in 2 spots. And then now I'm just going to draw that arc. I'm going to turn my paper sideways. I work better sideways. And I'm going to swing my paper. I actually don't move my hand. I just swing the paper. Okay. So now this intersects my line at 2 points. So these 2 points, let's label them. This one point A, this one point B. So now those 2 points are the same distance from P. They're this far from P if I haven't moved my compass yet. Okay, and so then now what I need to do is I need to come in and put my compass on point B. A lot of times I don't even move my compass at this point. I just want to make sure I reach at least halfway, because I'm going to come in and I'm going to draw an arc down here. Okay, from center of B, center of B, center of B, draw an arc, and then pick up my compass and do the same from A. So A, draw an arc. These 2 arcs should intersect. If they don't, then you didn't stretch your compass out far enough. So again, I put my compass point at B, draw an arc, at A, draw an arc, and then they intersect. And so I connect P. Let's call this intersection point Q. I connect P to Q, and guess what I have just made? I have just made a 90-degree angle. These are now perpendicular, so I can draw my little perpendicular sign in there. Okay, so those are now perpendicular. Okay, all right. Slightly new vocabulary. Really, these 2 words are words we already know. We're just going to put them together. Perpendicular means intersect at right angle. Bisector means what? Divide into 2. Let's use the symbol congruent pieces. Again, that's not the formal definition, but that's what we're going to use. It divides it into 2 congruent pieces. So a perpendicular bisector is a basically a line, segment, ray that goes through a segment perpendicularly that bisects it. So the perpendicular bisector of this segment AB. Okay. The perpendicular bisector here needs to intersect this at 90 degrees and divide it into 2 equal pieces. So it needs to go through the midpoint. So I don't know, let's call this M. So these 2 pieces need to be the same for the bisector part. And it needs to go through it at 90 degrees. So it really needs to do 2 different things. So let's call this line, that's point M, we'll call this line L. So basically, L needs to be perpendicular bisector. Line L needs to be perpendicular to segment AB. Okay. And L needs to go through the midpoint. Okay. And go through the midpoint. Okay. So then we say that L is the perpendicular bisector of the segment. Okay, you can't bisect a line. So like if I said bisect a line, you can't because the line has no ends. So this is really only for a segment. So the perpendicular bisector, let's put this up here, of a segment. It goes through the segment at 90 degrees and it divides it into 2 congruent pieces. Okay. So now let's go ahead and let's construct a perpendicular bisector. This is my favorite construction, one of my favorite constructions because it's so easy. Okay, so here I have segment AB. All I do is I put my compass at point A, my point at point A, compass at point A, stretch out farther than halfway, draw an arc above and an arc below. It doesn't matter if you go through the line, just draw an arc above and an arc below. I normally kind of do about a half circle type thing. Without moving your compass, come and put it at B and do the same thing. Arc above, arc below. Okay. So now I have 2 intersection points here. So guess what? If I connect those intersection points, I'm done. So if I draw a line to connect these intersection points, okay, there's my line. Not only have we created a 90-degree angle perpendicular, but we've also found the midpoint of this segment. These 2 pieces are congruent. So we use this method to not only find the perpendicular bisector, but if I need to find the midpoint, this is how we do it. Okay, we use that, we use this perpendicular bisector, constructing a perpendicular bisector to get it. Okay, all right, now we have some new theorems. Okay, we've got a set of 3. Yeah, I think we've got 3 new theorems today. The first one is the linear pair perpendicular theorem. Okay, if I have 2 lines intersect, the 2 lines intersect to form a linear pair, again linear side by side, congruent angles. Well, we know that linear pair, by the linear pair postulate, they're supplementary. And if they're congruent, well, supplementary, again, means add up to 180. If they're congruent, then that means that they have to be the same measure, so that means each one would have to be 90. So then that's the kind of giveaway, then the lines are perpendicular. So there was kind of the gist on the proof on these. Okay, so meaning if I have 2 lines intersect to form a linear pair, congruent angles, so let's call this angle 1, this angle 2. So in this an if-then form, if angle 1 congruent to angle 2, they're linear pair, they're congruent, then I know that line, I don't know, let's call this lowercase m, line M, and this line N. Then we know that line M is perpendicular, again, that big upside down T, to line N. Then we know that it's a 90 degrees. So if I know these 2 angles are congruent, then I know these 2 lines are perpendicular. That's our linear pair perpendicular theorem. Okay, next one, perpendicular transversal theorem. In a plane, important word there, they have to be in a plane for this next one. If it's not in a plane, then we don't know, meaning if the 2 lines aren't on the same plane, okay? But in a plane, if a transversal is perpendicular to one of 2 parallel lines. So let's draw a picture. So we have parallel lines. Okay, let's call this lowercase a and this one lowercase b. And we have a transversal here. And this transversal is perpendicular to one of these lines. So let's draw my transversal here. Let's name it T. Transversal T. It's perpendicular to one of the 2 lines. Okay, so if a transversal is perpendicular to one of 2 parallel lines, so basically if B is perpendicular to T and A is parallel to B. Let's make those parallel symbols longer. So A is parallel to B. So we know these 2 lines are parallel. This line, put an arrow on it, this line to denote parallel. So 2 arrows there, these 2 lines are parallel. This transversal is perpendicular to one of 2 parallel lines. Then it is perpendicular to the other. Then I know that A is perpendicular to T. So if I know this, then I know this one's perpendicular as well. Okay. But again, this is in a plane. If it's not in a plane, like if we have a line coming out like this, then it won't work. Okay. Because your transversal could be tipped up and it could have all kinds of weird stuff if we're not contained in a plane. Okay. The next one also is contained in a plane, again, in a plane. If 2 lines are perpendicular to the same line, then they are parallel to each other. So let's draw a picture. Here we have 2 lines. Let's stick with A and B. Line A, line B. And they're perpendicular to the same line. So let's go ahead and let's draw a line in. Okay. And let's call this line T. 2 lines are perpendicular to the same line. So if these 2 lines are perpendicular, so if A is perpendicular to T and B is perpendicular to T, then what do we know? So if A is perpendicular to T and B is perpendicular to T, if 2 lines are perpendicular to the same line, then they are parallel to each other. Then A's parallel to B. So what really changed from our last theorem is here we know they're both perpendicular to the same line. Again, there's my T and my T. So then I know they're parallel to each other. Again, because we're in a plane. On this other one, the perpendicular transversal theorem is I know one line is perpendicular to one parallel to the other, so then I know those two are perpendicular to each other. Okay, switches it around a bit. So we're going to actually use this diagram to prove the perpendicular transversal theorem. So again, if we look at the perpendicular transversal theorem, we start with if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other line. So this bit of information is going to be my given. And this is what we're trying to prove. Okay, so we know that the two lines are perpendicular and the other two lines are parallel. So here's my picture. So H and K are my parallel lines. H and J are my perpendicular lines. So let's start with our given. We'll go ahead and do this in 2-column. So our given is first H. We know line H is parallel to line K. And we know line H is perpendicular to line J. We want to prove. We're trying to prove here A is perpendicular to T. So we're trying to prove here that now K is perpendicular to J. K is perpendicular to J. We want to prove that there's a 90 right in there. Okay, so how we're going to do it. Again, statements and reasons. The plan. Well, first of all, we know the two lines are parallel. If the two lines are parallel, then I know corresponding angles are congruent. So here, angle 2 is 90, so that means angle 6 is also 90. Well, if angle 6 is 90, then that means they're perpendicular. So there's basically our verbal plan. So let's go ahead and let's put it in words. So we know H is parallel to K, and H is perpendicular to J. That's given. Okay. All right, so, okay, that bit of information is given right there. So if we know that, if we know perpendicular here, okay, if we know H is perpendicular to J, well, if we know perpendicular, then again, they draw that little square. Sorry for the bells. I'll be all right. We'll just work around it, okay? So here then we know then angle 2 is a 90-degree angle. We know measure of angle 2 is 90. How do we know that? We know that because of this perpendicular bit of information. So that would be definition of perpendicular. Definition of perpendicular could be more specific and put lines on the end. Definition of perpendicular lines. Okay, so if measure of angle 2 is 90, well, I know that, again, we want to connect 2 to 6. I know these two lines are parallel. 2 and 6 are corresponding, so I can say angle 2 is congruent to angle 6 because of that's our corresponding angles theorem. Okay, so angle 2 is congruent to angle 6. That's our corresponding angles theorem. Okay. So if angle 2 is congruent to angle 6, well, I know their measures are equal. The measure of angle 2 equals the measure of angle 6. Because if I know congruence, then I know their measures are equal. So that would be what? Definition of congruence? Well, if the measure of angle 2 equals the measure of angle 6, we know the measure of angle 2 equals 90, so I can put these two statements together because they both equal the measure of angle 2, and I can say that the measure of angle 6 then has to equal 90. Two options here. You could say substitution, property of equality, or transitive. And those are both properties of equality because we're using an equal sign. Well, if I know this is 90 degrees, well, that's what perpendicular means. So then I can state that K perpendicular to J. My reason for that would be definition of perpendicular. Okay. definition of perpendicular. And there, all done. We got to the end, QED. Okay, all right, here's an example. Here the diagram shows the layout of walking paths in a town park. Determine which lines, if any, must be parallel in the diagram. Explain your reasoning. Okay, so we want to look to see what we know here. I have a 90 degree here. I have a 90 degree here. In both of those 90 degrees, D is in both of them. This 90 degrees is by A and D. This 90 degrees is by B and D. So we know, let's write that down. I know A is perpendicular to D and B is perpendicular to D. So if I come up here using our lines perpendicular to transversal theorem, I have A perpendicular to T and B perpendicular to T. Both of them have that D in there. So we know that A is parallel to B, and we know this because of what? The lines perpendicular to a transversal theorem. Lines perpendicular to a transversal theorem. So I know these two lines. We can go ahead and mark them. These two lines here end up being now parallel. Okay. Now let's see. Do we know anything else? Well, I don't know anything about the angle with E between anything. What about C and D? Do we know C and D are parallel? Let's see, transversal here, but I don't know anything about these angles. Between C and D, we have this transversal here, but again, I don't know anything about those angles, so that might be it. A parallel to B because of the lines perpendicular to a transversal theorem. Okay, the end. So I want you to go ahead and write down the practice problems here on the back so you have them when you need them. Okay, do the practice. Seek out a teacher or classmate if you need help. Good luck.